that is ambient air entering into this, and there are water, hot water, which is coming from the condenser. The water will falls down, and this air will pick up the heat, and with the help of fan, the air will enter, and then it goes out. This is the hot air. Finally, heat is rejected. Okay. Now we completed a brief introduction of HVAC. Now we come to our topic of the day: recent trends in HVAC industries. Recent trends in HVAC: energy saving opportunities and improved efficiency. This is very important point. Recent trends in HVAC today, mostly on this point only. There are many measures available and many trends are going on in our HVAC industry. There are many R&D projects, there are many installations is happening, and why HVAC is so important, all these things we will see in the coming slides. Okay, the building information model. This is another big trend is going on. The building information model, like you would have studied in your engineering drawings, and there is a CAD, AutoCAD, you would have learned. This CAD is advanced version, is three-dimensional view of a building or a three-dimensional construction methodology. It is a BIM information model. Whatever you want to draw a building in a 2D environment, same thing will be shown in a 3D environment, so that a common man can easily understand without any visualization knowledge. If you are studying engineering, drafting or drawing, you need some kind of visualization knowledge. That is a basic requirement, so that you will see the orthographic, how it is, and for us, it is very important. Whereas now, the BIM technology, a common man can easily see the video. It's like a video with the help of yes. There is a power changeover happening. Sorry for the interruption. Is it audible now? Okay, thank you. Okay. The building information model is very important, as I said. With the help of virtual reality, we can see physically how the building looks like, how the air conditioned system is, what are all the systems inside the building. So the building information model is very important, and this is going on. And the green buildings concept and the net zero energy. Green building, the name itself suggests what are all the greeneries we can bring into the building, not only in HVAC, other thing, how to consume less energy, less water consumption, less power consumption. In terms of all measures, we bring it into the building so that we can reduce the energy consumed by the building. That is, green building concepts are completely available, and we are going for a green building. In India, we have a Green Building Council is there, and there are GRIHA, there are IGBC, Indian Green Building Councils. They are publishing and they are certifying the buildings for the green buildings, which are all following the principles and guidelines provided by the standard committees. And net zero energy, the term net zero, it means the power consumed by the energy consumed by the building as well as energy produced by the building, that is net, that is equal. So with the help of energy produced by the building is, we have to go for a renewable energy, either solar power or wind energy or biomass. We have to produce the energy with the help of renewable energy. You have to match the consumption. Then the net is zero, then you can say it's a net zero energy building. This is also a major boom. Now it is coming up everywhere. Ozone layer depletion, as we would have studied in physics in our school days, and global warming and climate change. Refrigerant is one of the culprit, it causes ozone layer depletion. And CFC is already phased out, the R12, it's already phased out. And there are alternate refrigerants are available. Even though we are using HFC refrigerants as a hydrofluorocarbons, R22, or now we are using HFC hydrofluorocarbons available, but still we are facing the global warming potential is still high, and the researchers are working for that, how to look for alternate refrigerants. So these are all the area now research is going on. Currently, we are following most of the HFC refrigerants change. And IoT, is one Internet of Things. It's a powered smart devices so that now Wi-Fi through the mobile phone you can switch on your AC and you can see what's happening with the help of app. You can see the power consumption by the chiller plant and pumps, how it's working. If you are in somewhere, you can see how your plant is running, whether it is working correctly. All those things you can see with the help of this IoT. So it's a major area with the digital technology and information technology. These devices are making our life better and controlling the HVAC system in a very closed manner. And growing importance of air quality, both indoor and outdoor, is a very important. Now we are in a COVID period, so the importance of air quality is coming up very highly. You see, we used to see in a Delhi in newspapers or in channels, we can see outdoor condition of Delhi is very poor and people are getting suffered because of the air quality. So then the outdoor itself is very bad. How you will maintain the indoor air quality? Big question mark. So this is the area now we have to think on the indoor condition, how to make it clean and get the clean air inside. So there are products available, there are techniques available how to clean the air, outdoor air, and get it into our conditioned area. And growing lifestyle, increased human life expectancy. Now the lifestyle, on even 20 years back, if you say if you have an air conditioner, it maybe looks like a luxury. Now it becomes your day to day, like you have a bike, you have a TV, like that. It's become a common, very common. It's not like something luxury. So growing lifestyle and increased human life expectancy. Now people says life expectancy also is increasing. So they are going for a air conditioning environment. So we need a sustainable technologies at affordable prices. So these are all the trends. Entirely I can see these are all the trends which is happening in the current HVAC industries. I am taking the first point, energy saving opportunities. Why is it so important? Okay, so why I have taken this point is, even though many points we have summarized, this point alone I am going to take. In this presentation, I am going to cover some important 12 topics on energy saving opportunities in a macro level, so that you will have an overall idea of the HVAC industries followed currently. There is a old saying, you can't manage what you can't measure. It's very apt for HVAC system. Why? Because in a commercial building, 40% or more than 40% energy consumed only by HVAC system. So you think, overall building power consumption, HVAC alone is consuming more than 40%. Sometime in India, we can see even 60% also. So such a huge power consumption, there is a big scope for saving, correct? So we are focusing today what are all the system and practices or technology followed in HVAC industry to bring down the energy saving possibilities. The first one, ASHRAE, I said, American Society of Heating, Refrigeration and Air Conditioning Engineers. They are publishing standards and practices to be followed in HVAC industries. So the 90.1 standard, which gives a guideline how to save energy in a building or in a HVAC systems. In India, we have ECBC, that is Energy Conservation Building Code. They used to periodically update and they publish the codes. So ECBC is an Indian standard. We have to compliance. That is whatever the minimum guidelines they are giving. Like in your exams, you have a passing percentage of 50 marks out of 100. 50 mark is a passing compliance. You have to get 50, then only you are passed. Same way, there are some minimum requirement is there with respect to the building certifications. Like that, a minimum requirement they have given. You are crossing the limit, you are going for the next level. Like that, they have provided building envelope. See, heat. When sun is a main, sun shining in a day, that is a major heat entering into your conditioned area. We call it building envelope, like roof. When sun shining, even you see in a noon time or in 2 o'clock, 3 o'clock, the outside ambient is very high. You will feel too stuffy and too hot, whatever it is. See the inside condition, the roof getting heated up, and the whatever roof heat or external wall heat, which will enter slowly into your conditioned area. So this is where the major heat enter into your buildings or space. We have to minimize this heat. How? You know the UA delta T. Heat is UA delta T. So A and delta T, you cannot have much playing, whereas U you can play. So that is the recommendations U factor, the overall thermal coefficient they are giving, how the building roofs should be constructed, how the walls should be constructed, what is the glazing material to be used. So these are all the guidelines available to bring down the, to cut the major heat entering into our conditioned space. Like that, many options, many recommendations are given by the ECBC and ASHRAE 90.1 standards. And minimum, as I said earlier, minimum energy efficiency requirement for a bigger, the big fatty guys, chillers, unitary equipments. Like unitary is like your window AC or room ACs and packaged air conditioners. So there are requirements. And insulation for ducting and piping. We have seen the air handling unit, which sends the air to the conditioned spaces via ducting. So these ducts should be insulated. And what is the insulation material to be followed? What is the R value? That is resistance value. For the same way, piping, we are sending the chilled water to the AHU and connecting to the chillers and pumps network. It should be insulated, and what is the R value to be maintained. So like that, many options, many recommendations are given completely in this standard. If you follow or comply accordingly, you will get the energy benefits and energy efficient motors. Like that, many opportunities are there. The second point is magnetic bearing centrifugal chillers. Now it's coming up like massively for a bigger plant. For centrifugal chiller, normally we go for a big plant where the big complex or big or can say infrastructure is there. There we are going for a centrifugal chiller. This magnetic bearing chiller, we no need to have a regular kind of the friction and wear and tear and a regular kind of bearings. It is working on the principle like magnetic levitations. You can see the bullet trains and all at a very high speed. It will not even having a contact on the rail. So like that is working on the magnetic levitation. Same way this compressor shaft, it is it is lifted because of the magnetic levitations. So you think there is no friction, there is no need of any oil, there is no fractional vibration, there is no mechanical contact at all. Then you think there is a complete reduction in the wear and tear and complete there is a sound, everything, all are savings, completely saving, and there is a huge power saving is there. In these chillers, we can get a better part load value. That 0.37 IKW per tier, that is input kilowatt. We are calling efficiency output by input. Same way COP we used to say, what is the outcome and input. Same way there is a input energy is your electrical energy. We are getting output as a refrigeration cooling effect. So here is 0.37 is very low, and even less than that also we are getting, and it is recorded as a 0.37 IPLV, integrated part load value. And some manufacturers are using R1233. As I said earlier, they have to look for alternate refrigerants. So this there are products available with a very low global warming potential. As I said earlier, there are global the concern now is coming up, global warming and climate change. We have to look for a eco-friendly refrigerant. So in this way, it's a sustainable product and sustainable energy progress. And water cooled centrifugal chiller with coming with the VFD. We will see now in coming up slides what is VFD and why it's so important. And this is a complete sustainable and environmental friendly product. As I said earlier, there is no much vibration, so the sound level is very less. And another important point is a very low starting current. Normally, any motor or any compressor at the starting time, it will suck the electrical power. So starting time, it need more current. So in this equipment, even that is also very less. It can start with a low starting current and longer life. Since there is no wear and tear, there is no much mechanical contacts, much wear and tear, no friction like that. So the life of the chiller also huge. You can see this is the typical cut section. Now we will see one small video so that we can understand the concepts. Yes. Okay.
சார் மேக்ஸிமம் வால்யூம் தான் வச்சிருக்கிறாரு, அது வரமாட்டேங்குது. பரவாயில்ல, விடுங்க.
Okay. Yeah, you can carry on, sir. You please proceed.
Compressor, now available in single and dual compressor models from 100 to 1,500 tons. Since their introduction in 2003,
That's okay.
these
Yes, sir. Okay,
magnetic-bearing
okay.
compressor chillers have proven their efficiency and reliability in thousands of installations around the world. Many of those chillers are installed in buildings certified as Leadership in Energy and Environmental Design, or LEED, Platinum, Gold, and Silver by the U.S. Green Building Council, as well as Energy Star certified by the U.S. Environmental Protection Agency. Now the next generation of magnitude chillers is available in models up to 1,500 tons. The magnitude chiller's exceptional efficiency is a result of the direct drive magnetic bearing compressor technology that eliminates the friction inherent in traditional centrifugal compressors that reduces efficiency. A digitally controlled magnetic bearing system replaces conventional lubricated bearings. The direct drive motor eliminates the need for a lubricated gearbox and associated power losses. The compressor shaft is the compressor's only moving component, and it rotates on a levitated magnetic cushion. As a result of its advanced compressor with an integrated variable frequency drive, the magnitude chiller delivers industry-leading efficiency. And with its positive pressure oil-free design, that industry-leading efficiency can be sustained throughout the life of the magnitude chiller because there's no oil to contaminate the chiller refrigerant or heat transfer services. Eliminating the oil management system also reduces the associated maintenance costs. Like all our centrifugal chillers, the magnitude chiller uses HFC 134A, an environmentally responsible refrigerant, with no ozone depletion potential and no phase-out schedule. This magnitude chiller is available with our Open Choices control feature, which allows easy integration with building automation systems using LawnMark, BACnet, or Modbus communication, eliminating the need for expensive gateway panels. A user-friendly touchscreen control is easy for chiller operators to learn and easy to use, providing chiller status at a glance. A small unit footprint means the magnitude chiller is ideal for renovation projects because it can fit in buildings where space is limited. Add up the reasons why a magnitude chiller is the most chiller for the money. High efficiency, reduced maintenance, sustainable, reliable performance. They add up to low total cost of ownership. The best reason to make your next chiller a Daikin Magnitude magnetic bearing chiller. Magnitude, ahead of everything else.
Okay. Is that my screen is visible? Okay. Thank you, sir. I'm proceeding. Now the third point, variable primary flow. We have seen there is a chilled water pumps which is handling the chilled water from the air handling unit to the chillers. Okay, whatever the water, it's getting the heat from the AHU coils and it is discharging to the evaporator. So the chilled water should be transported properly and it is returned back to the AHUs and again returned back to the chillers. So this system we have to maintain a proper flow and with respect to proper temperatures. So this how the design is. Conventionally, we have a constant primary system. Thereafter, the trend has come primary and secondary. So, what is primary and secondary? So, this is the chiller. Whatever we have seen just now, this is like a typical PNID diagram, I can say. So, these are all three chillers available. You can see these are all the pumps, primary pumps. Okay, the primary pumps, which is responsible for satisfying the chilled water requirement only on the production side. And there are pumps, this is called secondary pumps, which will take care of your AHUs. We have seen some AHUs. So how the load side, this is called the distribution side. So these side, whatever the variations, this completely taken care by these secondary pumps. So this called primary and secondary. So even now, mostly it is very common, primary pumps and secondary pumps. Now the trend is coming up, variable primary system. So there is no need of the secondary pumps. You can see there is no secondary pumps, only primary pumps. These primary pumps, earlier it is constant driven. There is no VFD. You can see VFD only on the secondary side. Now we are putting VFD into the primary side. So the variations in the water volume will be taken care by these VFD pumps. That is variable primary. That's why the word is called variable primary pumping system. There is no secondary. But in the evaporator, in the chiller, we need to maintain a constant water flow. Then only the refrigerant will pick the heat from the water. The refrigerant system is required, evaporator should have a constant flow. So we are maintaining with this primary variable system the minimum flow rate as prescribed by the manufacturer. We have to use the minimum, the working chiller will get the minimum water flow rate by the help of this flow meter and bypass valve arrangement. So this is the arrangement of the variable primary system, which gives less footprint. Is it not shared? Okay. So for this system, how it works, we will have a video. I'll just request Mr. Sindhil sir to share the video. Yes.
Because of its high energy efficiency and low installed costs, variable primary flow has become the industry standard for water-cooled and many air-cooled chilled water pumping system designs. In this video,
Okay, sir.
we will
Okay,
be
voice clear.
reviewing an example water-cooled system to learn what a typical variable primary flow pumping system looks like. Additionally, to highlight the key components of variable primary flow, also known as VPF, there will be several comparisons made to the second most popular pumping system, known as constant primary variable secondary flow, or commonly shortened to primary secondary. So what does a VPF system look like? Here's a typical design. Let's discuss the main components, the pumps, isolation valves, and the bypass valve flow meter tandem. Furthermore, you'll notice the chiller and air handling equipment. These components support the building load, but remain constant independent of the pumping design, so we won't be focusing on them. Okay, first the pumps. The two key differentiators here, versus a primary-secondary system, are that all VPF system pumps are variable speed, and they're all located upstream of the chillers. Whereas you can see in a primary-secondary system, there are two sets of pumps. They are located both upstream and downstream of the chillers, some of which are constant speed, the primary side, and some variable speed, the secondary side. This difference in design directly links to the higher efficiency and lower install cost for a VPF system. One additional item to note regarding pumps is that VPF pumps can be arranged in a chiller dedicated design, meaning they directly support each individual chiller, or in a header design, which is much more common. The headered approach allows all pumps to contribute to the system flow, independent of the number of chillers. This is typically preferred by the consulting engineering community, as it allows for improved system energy optimization opportunities. For example, when the system is operating at part load, a control strategy could be implemented to optimally balance the load across several pumps to help maximize system efficiency. This is a more difficult task with a dedicated pumping arrangement. Our second system components are the automatic isolation valves. Their purpose is simply to open and close as building load changes. However, a key design consideration is that they should be capable or sensitive enough to maintain acceptable flow rate changes through the chillers. This means the valve should not open too fast or too slow, but as dictated by the building control system for each unique application. And thirdly, we have our bypass valve and associated flow meter. The primary purpose of this duo is simply to maintain the required minimum flow rate through any operating chillers. In other words, based on the system load, the controls could tell the valve to open and allow fluid to bypass the coils to feed the chillers. This approach is compared to a primary-secondary system, where again there is a common pipe is shown, but no flow regulation, meaning fluid is able to flow in either direction to balance the system. However, the unwritten rule with this design is that the primary flow should always be equal to or greater than the secondary flow for optimal performance. Therefore, the flow would follow the same path as a VPF system. Lastly, as an alternative approach to the flow meter, some sites will use the differential pressure across the chiller's evaporator to estimate flow. And this approach works, however the flow meter's accuracy is typically preferred, as it yields the best chance to protect building owners against unnecessary energy consumption. These are the basic components of a variable primary flow pumping system. Thanks for watching.
Is it my screen visible? Is it my screen visible?
No, sir, not it.
Not yet.
No, sir, not it. Yeah, now visible, sir.
Thank you. Okay, we have seen variable primary flow pumping system, and now we move on to variable flow refrigeration system with heat recovery. You would have seen or heard that VRF, VRV technology. Actually, VRV and VRF, it is more or less same only. With respect to the manufacturer, there is some patent word VRV, and VRF is a very common. And this VRF, variable flow refrigeration system, if you take, for example, in a split air conditioning system in your home, you have an indoor unit which is inside the room, and there is an outdoor unit which is kept either in the terrace or wall or wherever it is. Only there is an indoor unit and there is an outdoor unit which is connected with the refrigerant piping system. Assume that in an office you have a more than 20 rooms. If you put each room with a split unit, okay, you need to have a 20 split AC outdoor units. Okay, assume that if you have a one outdoor unit and connected with all the indoor units, it's just for the explanation purpose. If you have many rooms having the indoor units and connected with one common outdoor units, for understanding purpose, this is like a VRF system. And with the heat recovery or heat pump system, the VRF system, now we have cooling only or heating only. There are heating for some rooms and there are heating for cooling for other rooms. But simultaneous heating and cooling is possible only by the recovery systems. So this is very new technology, and it is now coming up. I have used this VRF heat recovery system in London Underground project. So we have seen a good amount of energy saving through this VRF heat recovery system. In India, VRF normal system only, mostly it is used. That is without heat recovery, either cooling, mostly cooling applications only with respect to Indian conditions. This VRF heat recovery, you can see there are multiple indoor units having the cooling. You can see the blue shows that cooling is happening. This is the heating is happening. but it's all connected with the hybrid branch controller. It is connected to there is a branch controller. You see, this is the branch controller exploded view. You can see how it is looks like inside. These are all the refrigerant connection and only one outdoor which is connected. So whatever cooling required or heating required, this equipment is taking care with the help of controller and this hybrid branch controller. This huge saving for the spaces as well as the energy, and these are all the benefits we are getting. Less noise operation and less space occupation occupied for the equipments. We can avoid a lot of ductings and pipings also. You can see there is a only refrigerant system. Oh, sorry. Okay. The fifth point is demand control ventilation. The name demand. When there is a demand, ventilation will be provided. So it's very simple. So in building, as I said, we need a fresh air. See, you see, this is a typical office building with a 4-story building. Okay, there are people fully present, 80%, 50%. At times, maybe there is a lunch time or break time, whatever it is. There, with respect to people occupancy, we have to give the fresh air to the respected area. Normally, in conventional design, what we used to do, if it is 100 people, for example, if you take your college auditorium, it is designed for 100 people. We take 100 people fresh air. What is the amount is required? Like 20 CFM per person. We will throw always that 100 people fresh air. There is no control at all. Whereas in reality, in auditorium, only 50 people present. That means the balance 50 people actually extra we are taking from the ambient and cooling unnecessarily that fresh air. So this demand control ventilation, which works only for the people who are present, like if it is 50% people, only it will give 90%, 90. How it will know? There is a sensor called carbon dioxide. We human being take oxygen and exhale carbon dioxide. So carbon dioxide sensors will give you the close figure as we set in the control environment. So either CO2 sensor or occupancy sensor with respect to lighting sensors are available. With the sensors, we will count the people or requirement. With the carbon dioxide sensor, we will see the ppm level. What is the part per million of the CO2 present in the environment. Accordingly, this damper will open. You see, this is the arrangement. This is you can see there is a damper. When people are there, assume like this. This is the full people are present here. This is fully opened outdoor air. Accordingly, it is throttled. So the air entering into the building itself less. Here it's 200 CFM. Now it is reduced to 120 CFM. So the 80 CFM we are saving. The 80 CFM not only in the CFM saving, the 80 CFM we are reducing. Accordingly, our energy is saved. Only 120 CFM only required for current situation. So what is the demand? Accordingly, the fresh air will be given to the conditioned area. So that is called demand control ventilation. Due to that, we are saving a fresh air cooling load, and there is a lot of improvement in the air quality and energy savings. One way the improved air quality, it means actually it is required. What is required that we are giving? In that way, it is improved air quality. The sixth point, energy recovery wheel. In buildings, we have some amount of energy. We have to, suppose in a kitchen area or in an office area or in a general ventilation area. In hotels or big malls, some associated area like a toilet or other areas, we cannot use the air again and again in a recirculation. We have to throw out the air like a toilet air or some other air. But the air having a low temperature, okay, maybe 28 degree or less temperature compared to the ambient air. But the quality of the air is not good. It is not a breathable air quality. So we have to throw out the air, but the temperature point of view, it's having a low temperature air. The idea behind that, we have to take out the temperature, the available energy, we have to take that exhaust air. So this is the principle. Some amount of energy available, that suppose assume that this is a 28 degree C air we are taking out and sending to the ambient, and there is a fresh air entering at a 35 degree. What will happen? This 28 degree air will give the energy to the incoming air, 35 degree Celsius air. Here the arrangement is there is a wheel available which is connected with the motor with a belt arrangement. This will rotate very slow RPM, say 20 RPM. Okay, so it's having a very slow RPM. What will happen? This air having like a 28 degrees Celsius, but quality wise it is not a good air. That's why we are sending out. It's it's in contact with this rotating wheel. Okay, this rotating wheel takes this 28 degrees Celsius energy and it is giving to the pressure coming from the ambient, and it's cool down. Some amount of temperature is bringing down. So whatever it's bringing down, that is the saving on the incoming air. It may be a sensible saving or it may be a latent saving. As I said earlier, sensible is a change in temperature. We are removing means it's a sensible load is removed, and latent load, there is a change in only on the humidity level. There is no change in temperature, and there is a change in water vapor, or there is a change in humidity. We call it latent heat. So that is both here in sensible as well as latent recovery is possible in the enthalpy wheels. It's called enthalpy wheels, or simply we call energy recovery wheel, ERW. Some specification, sometime we go only for sensible. Mostly sensible is used. Sensible recovery is, so that is called HRV. There are wheels called HRV wheels only for the sensible heat recovered. This helps increase the efficiency and reduce the overall cost. Again, this is a fresher applications where we have the enormous energy available as a waste energy. As we can use that energy for the incoming fresher. This is in the same way what I explained earlier. This is another approach of cross flow plate heat exchanger. This is a plate heat exchanger. You can see this is a mechanical construction. It's nothing in the, there is no rotary equipment, or there is no power supply required, motor arrangement. This is a simple cross flow heat exchanger. One side the hot fluid is flowing like this. The other side of the plate, the cold fluid is flowing like a crash. That's why its name it shows crash flow. Okay, it is like perpendicular to each other. The flow is happening perpendicular to each other, and there is no physical contact. Both are in other sides of the each other. So it is installed in a packed one. This is the one, and with the help of filters. So whatever we have seen, the air, stall air coming from the room, it's sending out, and pressure coming in, it's exchanging the energy, and it is entering into your equipment. Pressure entering into the equipment or to the room. So this is the another example we have seen previously, energy recovery wheel. This is the energy recovery ventilator with the help of cross flow heat exchanger. And the eighth one is chilled beams. The term chilled beams, it is having two types. One is active and passive chilled beams. Now we are going to see active chilled beams with dedicated outdoor air system. This dedicated outdoor air system is completely giving the fresh air requirement of the various rooms. Assume like you are in a room A, room B, room C. There are different rooms are available. Okay, for that actually it's a zone. We used to call zones. Actually that is like a room only. For understanding purposes, assume like a rooms. Okay, here we need fresh air as well as the conditioned air. What will happen? This dedicated outdoor air unit taking care of both sensible load as well as latent load. In a room, latent load and sensible load, how it is defined? Sensible, we human being, having both sensible heat as well as latent heat. Your computers, electrical equipments, all these kind of things are sensible loads. And your building, roof, wall, glass, everything are sensible. So all these sensible load are taken care by this local unit called active chilled beams. It is kept here, and only the chilled water only flow inside. It will cool the room air, and there is a fresh air, the dedicated outdoor air, which is taking care of the complete room's latent load as well as the sensible load. So this whatever the air, outdoor air is coming, it ensures that the room dew point above the 2 °F. Why? Because these active chilled beams will not having any provisions for removing the latent load. Only sensible load only it will take care. So the total latent load taken care by this outdoor air handling unit. This is a dedicated outdoor air handling unit. With this benefit, we are getting energy saving and better air quality and space saving and less noise because of it. There is no much, like your arrangements. So less noise and uniform temperature. That is very important, uniform temperature, and suitable for sensible load applications like office areas. And radiant cooling. This is another one important area. Now it's coming up. Buildings are coming up with a radiant cooling. It's having two types. One is chilled slab and radiant panels. The idea in this radiant cooling concept, we have heat is transferred basically a conduction, convection, radiation. This is the radiation concepts. Mode of heat transfer is a radiation concept. Once the surface is cooled with the help of, there are tubes. Assume that this is your roof, your ceiling. Okay, there are embedded the concrete. Inside the concrete, the pipes are embedded, and inside the pipe, the chilled water is allowed to flow. What will happen? The chillness of the chilled water will slowly transfer the heat to the surface of this area. What will happen from this surface? It radiates to the space. So we are getting the cooling, from the surface cooling, we are getting radiations is happening. Once the surface is cooled, slowly the air enter into the space. You will feel, the chillness is coming from the roof. Normally what will happen, when the sunshine is there, the roof is much, get heated up and the heat entering into the space. Now, it is now ulta. Now the roof is cooled and the wall is cooled with the help of this radiant cooling, panels or slab. The roof is so cold, or ceiling is so cold, it is giving a chillness to the room. So the complete eradication of the, the envelope heat into the space. This concept is radiant cooling. With this, we can reduce enormous amount of, air side saving is there for the air handling unit side. So that is bigger saving. So energy saving is there and better thermal comfort, and there is a big gain on the operating cost, OPEX. And the chiller which is running also, with a very high temperature inlet, 16 degree. Normally chillers operate at 7 degree or 12 degree, 7 degree inlet and 12 degree outlet for the AHU. Here we can give 16 degree because for, it's a high temperature, a little bit high. It's suitable for office areas. Okay. Now it's the mechanical side, HVAC side. This is the underfloor air conditioning, underfloor air distribution. We have seen, as I said earlier, the conventional method of circulating the air. You can see anywhere in the air conditioning area, you would have seen supply also from ceiling and return also from ceiling. Okay. This topic, underfloor air distribution, underfloor. So what happened under the floor, air is circulated. So under the floor, air is circulated. There are grills wherever you want. You can fix this. Since there is no ducting arrangement, it's you have the free to play where you want to take up. Of course, there are some limitations. Okay, and with this grill, what will happen? Air will coming out from the bottom, and there is a return air arrangement. It picks the heat up from the people, PC, whatever the equipments are. Okay, the entire space is cooled by the incoming air from the floor, underfloor, and picks the heat up and it's entering into the return air duct path. So this is the arrangement. In conventional, we have to give AHU outlet temperature normally like 12 to 13 degrees Celsius. Whereas in this underfloor air condition distribution, we can give around 14 or more than 14 degrees Celsius. So there is a huge saving on the air side also. As well as the chilled water inlet and outlet, as I said earlier, AHU is required 7 degree in and 12 degree normally out of the chilled water. Here it's chilled water in and out also is higher. So both air side as well as on water side, huge energy saving is possible. And because of the underfloor, there is a ducting is there is the absence of ducting, and there is a low velocity. Your ESP, external static pressure of the fan also reduced, and it's less noise, suitable for the office environment. We have seen so far the 10 energy saving opportunities in the HVAC. Now on the electrical part, as I said earlier, VFD, variable frequency drives. Okay, variable frequency drives the name says varying the frequencies. In India, we have electrical power supply 50 hertz. You would have seen the 50 hertz. So our aim is by changing the frequency of the AC current, how to change or reduce the speed so that we can save the energy. You can see the speed of the motor is equal to 120 F by P. Okay, for F, this is the frequency. Here only we are going to play. Normally, the general current available in India, 50 hertz, as I said. If you reduce the hertz, we can definitely reduce the speed. Whereas the law, there are affinity law says when you reduce the speed, your cube of speed, your power saving is there. So that is a proportion. If you reduce 50%, suppose if it is running 100% speed, now you are reducing into 50% speed. That means 0.5 power 3. It is around 12.5%. That means 87.5% straight away saving. So you think when it is working now in 50% speed, you are saving 87.5%. So that much huge saving is possible by putting the variable frequency drives. This is the schematic representation. This is the fixed AC current, sinusoidal wave current, 50 hertz, and it is converting into a DC, and finally we are getting variable AC. That's what I said. Changing the frequency, it may be 35 hertz or 40 hertz. We are changing the frequency accordingly. The speed of the motor is changing. We are getting the benefit on the power side. Now we have seen commercial side some 10 points and 11 points on 11th point on electrical. It's the 12th point on the residential side. This you would have seen most of the product, maybe fridge or in your air conditioner. This label you would have seen. Okay, in advertisement also the government says more star, more savings. If you get 5 star, that means it is more energy saving equipment. If you have a less stars, accordingly you will get the energy savings. So this Bureau of Energy Efficiency Standards in India, they are publishing. This is the standard for the coming years in 2021 to 2023. They published each star means what is the minimum energy it should consume. So here it is available. Accordingly, you can see ISER 4.2 they mentioned. So there are standards. Accordingly, the equipment is rated and the ratings are checked, and the labels are given. What is a star? So people used to say more star. You buy the more star if you are continuously using the product. Suppose in a split unit you are continuously using, you can go for a 5 star. You are very occasionally you are using, you can go for a 3 star. Now inverter AC also has come up with a much savings. So in residential side is again there are energy saving opportunities are coming up huge, and go for a more star rated products. Not only on air conditioner, anything you buy, you go for a more star rated one so that you can save energy even the residential areas. With this, we completed our recent trends in HVAC topics on energy saving opportunities. Now we are entering into the part 3 for the career opportunities in the field of HVAC. ASHRAE, and in India it is ISHRAE, Indian Society of Heating, Refrigeration and Air Conditioners. You can see in their portal they used to publish. Okay, there is a job junction, and they you can see. Okay, these websites they publish. So HVAC industry, how the future. So let's see. Before that, ISHRAE membership for the students, you have a membership fees is very optimum, and I can say people can be a member so that you will get the industry updates from the ISHRAE. And this is a message from the chairman, ex-chairman of the Institute of Excellence, ISHRAE Institute of Excellence. You see, this is the potential of HVAC industry is having. The CAGR of 12 to 14%. Okay, the CAGR of 12 to 14%. The industry is growing, expected to grow at 12 to 14%. Comparatively, this is the best industry, which you can see the growth rate is highly positive side. Okay, of course, this is some 2 years old data, but even now it is not so low. This approximately holds good. So it's a very good potential. As a young engineers, you are all coming out of the college, you can look for the potential of the future where lies. Okay, so personally I would say you think where the potential is there, so accordingly you choose your career. So this is one of the potential area where you can look for. Okay, HVAC as a profession, employment side. If you want to go for employment, these are all the positions available. After some time, you will see there are sales engineers, design engineers, installation projects. You need site engineers, and of course, equipments to be commissioned and it should be handed over. So, commissioning engineers and maintenance engineers and operating who are running the project, running the site. They are called operation and maintenance engineers. And there are opportunities in the government enterprises. It's also available. So, in the employment side, we want to take up these kind of professions. Over a period of time, once you get knowledge on the subject, once you are matured enough, you have self-confident and you have opportunity to go for a self-employment as a HVAC consultant, or you can have an energy manager and auditor. B is every year conducting energy auditor and energy manager exams. So being HVAC side, you can go for that, getting these certifications. You can say energy auditor and energy manager, and start your own industry for producing the components of the HVAC industry. As I said, grills, there are many components which can be uh, manufactured in India. And government also now is supporting for such activities. So you can start over a period of time, your own component manufacturing and start your own contracting company. This all depends on the individuals. Okay. For this field, what are all the skill set is required? If you are working for an application area, where I said, you need a hospital, means you should know the environment, the terminologies, and what are all the rooms application wise, what it is used for, what is required. Okay, so that application knowledge you should have, so that you can read some ASHRAE books. Guidelines are available, fundamentals are available, and internet sources are much available. You can get, you can go through, you will understand, and of course some practical knowledge is required that you will come to know while working only. Okay, then coordination with the architects, structural engineers, and the other discipline engineers. So that is a working knowledge, and clear communication, which you can practice it. And the clear communication, either verbal or in writing. So the communication should be very clear. Why? Because now it's very important one as a soft skill. And innovation and cost-effective HVAC solution. Being a client nowadays, is cost is matters, which drives always the solutions. So you have to give innovative solution as well as a cost-effective one. Leadership and teamwork. This is again a management term, and we have to work with all the people and see that it is done. The result-oriented activities. And softwares. There are HVAC softwares which help us to calculate the cooling load and to draw. As I said earlier, BIM. This is I suggest personally, who are all coming out now, not only in B as a degree, you can also parallelly study the BIM software, so that your profile will be much given importance. BIM information, building information modeling. Need the following subject knowledge. Since you are currently studying, so you focus on your thermal application, thermal engineering, fluid mechanics, and electrical and electronics. So these are all the area you can concentrate on your subject, so that when you look for subject, you can easily understand and pick up the knowledge required level. I think with this we have come to an end, and some of reference I have taken, I have given the references. I hope you would have in this last 1 hour, you would have gained some knowledge, and in a very macro level. Okay, I have taken this webinar the best what I can give, and I hope you people have enjoyed and you would have taken some knowledge. And this is the time for question and answer. Now I open the floor to question and answer. Yeah. Yes.
Sir, thank you, Tyagarajan sir. Thank you, Tyagarajan sir.
Thank you,
Our
sir.
principal ma'am is entering into the program. Ma'am, welcome, ma'am.
Sir,
Principal
happy
ma'am,
joining.
welcome,
Happy
ma'am.
joining.
Say a few words.
First of all, I would like to thank Mr. K. Tyagarajan sir, Principal Engineer from Petrofac, for having spent his vast experience, knowledge with our students and faculty members. Thank you so much, sir. On behalf of our management, we would like to thank you for having accepted our invitation and raising this wonderful webinar. Actually, for Petrofac, by 2015, we had Mr. Krishnan sir from Petrofac has visited our campus, and we have discussed for signing MOU and also establishing Center of Excellence in our institution. So in
Great.
that way, in that way, the association with Akshaya and this Petrofac is really a long way to go. And also, one of our students, I mean, previous year batch student, is presently working in Petrofac. Hope you are aware. Uh,
Okay.
yeah, he is doing some great contribution in Petrofac, as I heard about that. Myself, even Raju sir has got an experience. Anyway, the one day, alumni has come to our campus, visited our campus, and we asked him, like, okay, what are you doing? He said, ma'am, I am in HVAC industry. I am working in HVAC industry. So how could this possible be asked? He said, the moment I passed out from this campus, he did a course in HVAC. He did course in Cochin, and because of that, he could able to work and he could able to associate with Gulf countries in HVAC domain. So this HVAC domain is really evergreen and having much demand, as our guest rightly explained to all of us. So students, you have to clear all your doubts and what are all the opportunities available in this forum, in this domain also sir has explained. So please clarify your doubts. Thank you, sir. Thank you for your informative session.
Thank you, madam.
Thank you, ma'am. Any queries, clarification, you please ask participants and my dear students.
Yes, sir.
Any queries?
Okay. Okay. HVAC software, as I said, for cooling load calculations, currently in India, HAP, HAP, hourly analysis software. This is very common and it is utilized by most of the engineers. You can learn HAP. This is the cooling load calculation purpose. And some Excel sheet is there. First, you study, the carrier heat load calculations are available, and ASHRAE fundamentals are available. It's all available in the internet itself. You can have, you can download and you can read. And some Excel sheets also available. Spreadsheet we used to call the Excel spreadsheet. That will give you more clarity. Since you are starting currently as a fresh, you first work it on the Excel sheet, understand the concepts, how your studied heat transfer concepts are working really before working into the software. Why? Because software sometimes you don't know what is the in. We used to say, garbage in, garbage out. So the input is wrong, your output you don't know until you really see the outcome. So first you work it on the Excel sheet, spread or Excel sheet with the concepts you learned in the engineering and see the outcome. With the help of that outcome, you work it in the software, as I said, HAP. Then you see the differences. What is the Excel sheet outcome and what is your software outcome? I hope this will give you some idea what the software is giving. I hope I answered. Yeah. Next. Upstream and downstream. See, actually, yeah, see, this upstream and downstream, it depends on the pumping side. Actually, you can see. Are you able to see my screen? Sir, are you able to see my screen? Okay. See, this is the pumping side. Okay, this is the pumping side, upstream and downstream. We used to call as a production side as well as a distribution side or load side. So this is the
No,
upstream
sir.
and
No,
downstream.
no, sir. No.
What? No? You can't see my screen? Excuse me? Are you able to see my screen?
Yes,
Is it audible? Okay. Okay, this is upstream and downstream. Okay.
No, sir. Not seen.
Not visible. Good. I think it shows you are presenting. I hope I am presenting. Is it not visible? My screen, is it visible, sir? Okay, thank you. Next question, please. Technically speaking, like you would have studied black body, white body, gray body, that is something different, actually. That is different, actually. Technically speaking, colors, coating only matters. What kind of coating you are providing? Colors is not a matter. Colors is just,
Not visible, sir.
No, I'm not sharing. I'm just speaking. Okay, colors is not a big deal actually. If a white building means everything it absorbed, it's a white building, white material, something. The color is what is the coating of the material only matters. As I said earlier in slide 1. See, this is the building envelope, the external walls, and this one. The coating only matters mainly on the outer side of the building. What kind of coating material is used? Even though if it is a black color or a white color, it will not give you much differences. The material only matters. What is the material you are using? That is very important. Generally, there is a understanding that white means we studied white body. White body means it will not absorb much heat. Black body means it is absorbing the entire heat. So that is on the technical side. Black body means it is absorbing the total heat. That is on the technical side. It's not on the color only. Yes. Next. Any other PPT you want to share? Okay, I'll share. Any other question? If you have any common question you want to ask, even in your split AC general, don't hesitate to ask questions. You can ask questions. Okay. I hope with this, any more questions, then we can wind up the session.
Any queries, Sendhu sir? Next. Sendhu sir. Sendhu Kumar sir.
So here I have a note. I'm appreciating Dr. Nagaraju sir, HOD of this Mechanical Engineering Department, and Dr. Sendil Kumar sir for their untiring
Yes,
effort.
sir. Thank
in
you,
making this webinar.
Tyagarajan sir.
Thank you, sir.
In spite of your busy schedule, we are spending the time to
Thank you, sir.
deliver
Honestly, I have to
the
thank
lecture
Mr.
for
Professor Dr. Sendil.
webinar.
Professor Dr. Sendil Kumar sir, continuous follow-up and encouragement for this day presentation.
Sir.
He is a motivator for me for having presenting today. Thank you, sir. And I thank all the participants who are all presented and
Yes,
very
thank you, ma'am. Thank you, ma'am.
actively listening and asking questions.
Give me a
Thank
vote of
you.
thanks.
Okay.
பாலமுத்து மணிகண்டன் இருக்கீங்களா லைன்ல?
இருக்கேன் sir. A very good afternoon to all. It gives me an immense pleasure to deliver the vote of thanks for this event. To all dignitaries assembled here, I would like to thank our chief guest, Mr. K. Tyagarajan sir, who honored this function with his inspirational thoughts. I would like to thank our beloved principal, staff members, students, and participants for making this function as a grand success. Once again, I thank one and all present here. Thank you.
Thank you all. Sunil sir, I am closing the presentation. Okay, no? Thank you. Thank you. Thank you. Thank you.
செந்தில் சார் கட் ஆயிருச்சு திடீர்னு, சாரி, நெட்வொர்க் ப்ராப்ளம். சார் கிளம்பிட்டாரா? சார் இருக்காரா? சரி சரி, ஓகே. ஹலோ, கிளம்பிட்டாரா? ஓகே ஓகே சார். மேம் கிளம்பிட்டாங்க, பிரின்சிபால் மேம். சரிங்க சார், ஃபீட்பேக் லிங்க் அனுப்பிச்சு விடுங்க, கேட்டுகிட்டே இருக்காங்க. ஓகே 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 சார், தேங்க்யூ ஆல் த பார்ட்டிசிபென்ட்ஸ். அந்த லைவை கட் பண்ணிருங்க, ரெக்கார்டிங் கட் பண்ணிருங்க.